start in about 1 minute. Today we'll be in section 9.7. This is another section on graphing quadratic functions, but in this section we will discuss how to graph quadratic functions by transformations horizontally and vertically. Okay, the setting starts out the same. Let the variable y be a quadratic function of the variable x. Then its standard form is y equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. Every quadratic function, y equals ax squared plus bx plus c, can be written in the vertex form. So the vertex form is y equals a times the binomial x minus h squared plus k, where the ordered pair hk is the vertex. So that means the number h is equal to negative b over 2a. A couple of graphs to illustrate. If you have a greater than 0, that means the parabola opens upward. And if the parabola is right here, then the vertex is the ordered pair hk. So this is referred to as a transformation. If we started out with a parabola whose vertex is at the origin, so think of a parabola that has exactly the same shape as the parabola up here where the vertex is hk. So in this picture, we start out with a parabola with vertex 0, 0. And then if we shift the parabola to the right, or translate it or transform it to the right, this vertex is the ordered pair h0. And then from the green parabola, if we shift it vertically upwards to where the black parabola is, there's a vertical translation of k units. So once again, if we start with the red parabola where the vertex is 0, 0, shift it to the right or horizontally h units, and then shift that vertically k units, and we get the parabola that we want. Hey, the same sort of thing can happen if you have a parabola that opens downward if the value of a is negative. Then this parabola has a high point for the vertex, and that's hk. But in both of those, the vertex form looks like this: a times x minus h squared plus k. What we'll learn how to do today is rewrite quadratic functions from the standard form to the vertex form. So in other words, we'll start with quadratic functions of the form y equals ax squared plus bx plus c, and using a little bit of algebra and arithmetic, we'll transform it to its vertex form, y equals a times x minus h squared plus k. The way that the technique that we'll use is the completing the square technique. And that should make sense, because if you remember, when we complete the square, we create a perfect square trinomial. And a perfect square trinomial is the result of squaring a binomial. And in the vertex form, y equals a times x minus h squared plus k, we see that we are squaring a binomial. So there's a perfect square trinomial involved. Okay, we'll do a bunch of examples, and I'll show you step by step how to transform a quadratic function from its standard form to its vertex form. Okay, here's our first example. Y equals x squared minus 6x plus 8. In the first step, we factor the leading coefficient out of the x squared term and the x term, but not the constant. In this one, the leading coefficient is 1. And when you factor 1 out of something, nothing changes. But we'll go through the motions anyway. So the leading coefficient is 1. Factor that out of the x squared term and the x term. So we have x squared minus 6x in parentheses. I'm leaving a little bit of space here, and you'll see why in a minute. But the constant, we leave that alone, and we put that on the outside, plus 8. Okay, in the next step, we're going to add 0 inside the parentheses. On a quiz or a test, if you're showing your work, make sure that you show several steps. If you try to do everything in one step, then it's hard to read and hard to grade. So, I mean, that might be a strategy, make it hard to read so that, but if you put in several steps, then it will be easier, probably easier for you to work on, and also easier for me to look at. So in the next step, we're going to add 0. What form will 0 take? Well, inside the parentheses, we have x squared minus 6x, and we're going to create a perfect square trinomial by adding a number to x squared minus 6x. We've done that before. We've learned how to do that before. So if we have x squared minus 6x, how do I know what number to add to get a perfect square trinomial? Well, I take half of the coefficient of x and square it. The coefficient of x is -6. 1/2 of that is -3. And then I square that number, -3, which is +9. But we don't want to change the meaning of the quadratic function, so we're going to write +9 -9. In other words, we're adding 0. If you add 0 to something, you're not changing its value. Here we're just changing its form by adding 0 in the form +9 -9. In the next step, inside the parentheses, we're going to keep the perfect square trinomial, the x squared minus 6x plus 9. We want to keep that part, x squared minus 6x plus 9. And then in this line right here, apply the distributive property, multiply 1 times -9, which is -9. So outside of the parentheses, we write -9 together with the +8 that is already on the outside. So the reason the -9 is on the outside is because we applied the distributive property by multiplying 1 times -9 and moved that outside. In the next step, we can write the vertex form. Y equals 1 times a binomial squared. This is a perfect square trinomial, so we can write it as x minus 3 squared, and then the -9 plus 8 is -1. When the leading coefficient is 1, you don't need to write it, but I'm just writing it here to illustrate what we do in general. Okay, so the vertex is the ordered pair 3 for x and -1 for y. Okay, so 3, -1 is the vertex. We know the parabola opens upward, so we should find a couple of other points. This is primarily an exercise on writing a quadratic function, changing it from standard form to vertex form. But we still want to graph it. And we also want to find the x and y intercepts. So we can find the y-intercept the same way that we did yesterday. And we can use the standard form to find the y-intercept. Every y-intercept has an x-coordinate of 0. And when x is 0, the y-coordinate is 8. So 0, 8 is a point on the graph. So we could plot that point, 0, 8. We could use symmetry to find another point that corresponds to the y-intercept 0, 8. Can you tell what ordered pair that is? 6, 8. Yeah, the vertex 3. So x equals 3 is halfway between the points that are symmetric. So since the y-intercept is 0, 8, then another point, 6, 8, must also be a point on the graph. So they're on the same horizontal line. But let's find the x-intercepts. So let's borrow the space up here to find the x-intercepts for this function. Okay, if we use the standard form, every x-intercept has a y-coordinate that's equal to 0. So we just solve this equation, 0 equals x squared minus 6x plus 8. We can always use the quadratic formula, but this one can be factored pretty nicely. Do you see what the two factors are? So one of the factors is x minus 2, and the other one is x minus 4. So the x-intercepts are the ordered pairs 2, 0 and 4, 0. So we can plot those 2, 0 and 4, 0. And then we can draw the parabola. All right, the next one's a little more involved because this time the leading coefficient is 2. So rewrite this quadratic function. It's given in standard form. Let's write it in vertex form. Okay, the leading coefficient is 2. So to get it into vertex form, we factor 2 out of the x squared term and the x term, but we leave the constant outside of the parentheses. So we have 2 times the quantity x squared minus 8x. I'm leaving some space inside the parentheses for the adding 0 part, and then the plus 34 stays on the outside. Okay, now we turn our attention to what's inside the parentheses. We're just focusing now on x squared minus 8x. So in the next step, we're going to add a number and then subtract the same number. But the number that we add to x squared minus 8x will create a perfect square trinomial. Okay, so in the next step is the adding zeros step. What form will 0 take? Okay, so what should I write on the inside of the parentheses?
Minus 16 plus 16.
Yeah, the other way around.
Oh, plus
Yeah.
16 minus 16.
Yeah, plus 16 minus 16. Yeah, so when we focus on x squared minus 8x, we take half of negative 8, which is negative 4, and then we square negative 4, which is positive 16. So the x squared minus 8x plus 16 is a perfect square trinomial. But to maintain equality, we subtract 16. All right, then what do we do in the next step? In the next step, inside the parentheses, we're going to keep the perfect square trinomial inside x squared minus 8x plus 16. But then we apply the distributive property, multiply 2 times negative 16, and put that number on the outside of the parentheses. So 2 times negative 16 is negative 32. So on the outside of the parentheses, we put minus 32 together with the plus 34 that's already on the outside. And then in the next step, we can write the vertex form. So we write y equals 2 times some binomial squared. And then on the outside, we have minus 32 plus 34, which is plus 2. So on the inside of the parentheses, what's the binomial that we square to get x squared minus 8x plus 16?
X minus 4.
Yeah, it's just x minus 4. And now it's in vertex form. And we can write down the vertex. That the x coordinate of the vertex is the number that we're subtracting from x on the inside of the parentheses. So the x coordinate is 4. The y coordinate of the vertex is the number that is added on the outside. Since we're adding 2, the vertex is 2. The y coordinate of the vertex is 2.
How come it's not negative 4?
Well, think about what the value of x, the question was, how come the x coordinate is not negative 4? If you replace x with negative 4, then negative 4 minus 4 is negative 8. Negative 8 squared is 64. 2 times 64 is 128. 128 plus 2 is 130. But the y coordinate of the vertex is not 130, it's 2. So just note that if we replace x with 4, 4 minus 4 is 0. And then the y coordinate is 0 plus 2, or 2. Yeah, that's a good question to ask. That's a fairly common misunderstanding at first. But just think about, well, if you forget, should the x coordinate be positive 4 or negative 4? Well, replace x with 4, then replace it with negative 4, and you should be able to reason it out and come up with the correct result. Okay, the vertex is 4, 2. The ordered pair 4, 2. The parabola opens upward, so there are no x-intercepts. Okay, so no x-intercepts. You would have found that out if you had replaced y with 0 and then solved the quadratic equation. The two solutions are non-real numbers. And then that tells you that there are no x-intercepts. So no x-intercepts. There is a y-intercept. What's the y-intercept? Yeah, when x is 0, the y-coordinate is 34. Okay, so that's going to be off the grid. But we can find a couple of other points if we just use the function as a formula, and we could use the standard form or the vertex form. We already know that we have the ordered pair 4, 2. When x is 4, the y-coordinate is 2. So a couple of other points that will be fairly easy to work with if we pick x to be 3 and then pick x to be 5. So since the ordered pair 4, 2 is the vertex, is there anything we can say about the y-coordinate that goes with x equals 3 compared with the y-coordinate that goes with x equals 5? They have to be the same y-coordinate because of symmetry. Okay, but even if you don't recognize that, you could still come to that same conclusion. Okay, so which form do you want to use, the standard form or the vertex form, to find the y-coordinate that goes with x equals 3? If we have the correct vertex form, then it doesn't matter. We can use either the standard form or the vertex form. So when x equals 3, I'll use the vertex form. Y is equal to 2 times the quantity 3 minus 4 squared plus 2. 3 minus 4 is -1. -1 squared is 1. 2 times 1 is 2. 2 plus 2 is 4. So the y-coordinate is 4 when the x-coordinate is 3. So we have that point on the graph. By symmetry, we should be able to conclude that the y-coordinate that goes with 5 is also 4. Okay, but let's pretend like we don't know that. When x is 5, maybe we should use the standard form just for practice. When x is 5, use the standard form to find the y-coordinate. So we get y equals 2 times 5 to the second minus 16 times 5 plus 34. 5 to the second is 25. 2 times 25 is 50. Minus 16 times 5 is minus 80. 50 minus 80, and then plus 34. 50 minus 80 is negative 30, and then negative 30 plus 34 is 4. So the y coordinate that goes with the x coordinate 5 is also 4. So we can plot those points and sketch the parabola. Okay, the ordered pair 3, 4. The vertex 4, 2. And then another point 5, 4. And then the parabola opens up, of course. If we just review a little bit from what we talked about yesterday, if we begin with the standard form, y equals 2x squared minus 16x plus 34, and then use the vertex formula for the x coordinate of the vertex, h equals negative b over 2a. So in this one, for y equals 2x squared minus 16x plus 34, b is negative 16 and a is 2. So negative b is the negative of negative 16. And in the denominator, 2 times a is 2 times 2. So we get positive 16 divided by 4, which is 4. Okay, that's another way that you can verify that when you transform it into vertex form, that's another way to verify that the x coordinate should be 4 as opposed to negative 4. Okay, let's look at the next example. Okay, I'll give you a few seconds. Rewrite this quadratic function so that it's in vertex form. So I'll give you 30 seconds or so. So you can just type in the vertex as an ordered pair. Well, it's been more than 30 seconds. Now let's start. Y equals 3x squared plus 30x plus 72. The first step, factor 3 out of the x squared term and the x term. So 3 times x squared plus 10x. Leave some space and then write plus 72. The next step is the adding 0 part. Inside the parentheses. So what form should 0 take? So we want to create a perfect square trinomial from the x squared plus 10x part. So we're focusing on x squared plus 10x. So we take 1/2 of 10 and square it. 1/2 times 10 is 5. 5 squared is 25. So the form 0 takes is plus 25 minus 25. In the next step, we have 3 times the perfect square trinomial, x squared plus 10x plus 25. And what goes on the outside of the parentheses?
Minus 25. Negative 25.
Nope. We apply the distributive property. We multiply 3 times negative 25.
75.
So we write minus 75 together with the plus 72 that's already on the outside. So don't forget the 72 that's already out there. Okay, so when you're practicing these, make sure that each step is complete and accurate. Each one of those steps should be equivalent to each of the other steps. In the next step, we can write the vertex form. So we have 3, and then the perfect square trinomial in factored form is x plus 5 quantity squared. And on the outside, we have minus 75 plus 72 is minus 3. Yeah, there's a question, is the formula for finding the perfect square 1/2 of b squared? Yeah, that's what we did on the inside of the parentheses. We're just focusing on, we were just focusing on the x squared plus 10x. So b is 10, so 1/2 of 10 is 5. 5 squared is 25. All right, what's the vertex? What's the ordered pair for the vertex?
-5, -3.
Yep, -5 for x and -3 for y. And you can verify that the x-coordinate, -5, is -b over 2a. So why don't we do it? The x-coordinate of the vertex is -b over 2a. So let's just verify that. B is 30 and a is 6. So -b is -30 divided by 2 times 3 is 6. -30 divided by 6 is -5. So that verifies it. Let's see, the vertex is below the x-axis, -5, -3. That's below the x-axis. The parabola opens upward. So what does that mean? Yeah, there are 2 x-intercepts, so we should find those. We can write down the y-intercept. The y-intercept, x equals 0 is always the x-coordinate of the y-intercept, and when x is 0, the y-coordinate is 72. To find the x-intercepts, we replace y with 0 and then solve the quadratic equation. So 0 equals 3x squared plus 30x plus 72. Okay, this is an ordinary quadratic equation. The variable y has been replaced with the number 0. So we could solve this quadratic equation. And since we're just solving a quadratic equation, we can divide every term on both sides by 3 to get rid of the clutter that's in the way. So divide every term on both sides of this by 3, we get 0 equals x squared plus 10x plus 24. And we can pretty easily solve this by factoring. You see what the 2 factors are this time. So 1 times 24 is 24. 2 numbers that have a product of 24 and a sum of positive 10 are positive 6 and positive 4. So the 2 factors are x plus 6 and x plus 4. The solutions to this quadratic equation are x equals -6 and x equals -4. So the x-intercepts are the ordered pairs -6, 0, and -4, 0. All right, so let's go ahead and sketch this parabola. Okay, the vertex. So my graph is not extremely accurate, but the vertex is -5, -3. An x-intercept at -6, 0, and another x-intercept at -4, 0. And then the parabola opens upward. All right, let's work on the next one. This time we have y equals negative x squared minus 8x minus 12. So we want to rewrite it so that it's in vertex form. The leading coefficient is -1. In other words, a is -1. So we want to factor -1 out of the first two terms, out of the x squared term and the x term, but not the constant. So we write y equals -1 times x squared plus 8x. Leave some space for the adding 0 part, and then put a right parenthesis, and then the minus 12 is on the outside. Then in the next step, we're going to add 0, and in the process, create a perfect square trinomial. So now we're focusing on x squared plus 8x. So we take 1/2 of 8, which is 4, and then square that number, which is 16. So the form that 0 takes is plus 16 minus 16. So now we have a perfect square trinomial. And then in the next step, we're going to get y equals -1 times the perfect square trinomial, the x squared plus 8x plus 16. And what goes on the outside of the parentheses?
16, positive 16.
Yep, plus 16 together with the minus 12 that's already there. Yeah, so when we apply the distributive property up here, -1 times -16 is positive 16, which that goes on the outside of the parentheses, together with the minus 12 that's already on the outside. Okay, so once again, make sure that each of the steps is equivalent to all of the other steps. And also remember not to do too much work in a single line. So 4 steps is pretty good. In the next step, we can write the vertex form. Y equals -1 times the binomial x plus 4 squared, and then plus 4. Okay, so on this one, the vertex the x-coordinate of the vertex is -4, and the y-coordinate is +4. The vertex -4, 4 is above the x-axis, and the parabola opens down because the leading coefficient is negative. So it has 2 x-intercepts. So to find the x-intercepts, replace y with 0. 0 equals negative x squared minus 8x minus 12. To make the arithmetic easier, I would divide every term on both sides by negative 1 to get 0 equals x squared plus 8x plus 12. And this factors really nicely. The two factors are x plus 6 and x plus 2. So the x-intercepts are the ordered pairs negative 6, 0, and negative 2, 0. Okay, we are now out of time. We'll continue with these tomorrow. We're in the same section, 9.7 tomorrow. So that's all for today. Go ahead and sign in for attendance.